I want to record myself solving the upcoming problem for the day 4 of this month. Only 9 seconds and 8 seconds left. 6, 5. Let's see. I may use this to think. Okay, maybe it's available now. Is it? Okay, yes. Okay, there's a medium rated problem. Given an integer n, return true if it is possible to represent n as the sum of distinct powers of 3, otherwise return false. An integer y is a power of 3 if there exists in such that y equals to 3 to the power x. So I just have to see log 3 base of n. I don't really know till now how I should approach this. I don't think we have a log 3 base n built in any in at least C++. I don't think we have that. So what should I do? Maybe uh, maybe try to get as much power as you can, the highest power as you can uh, take that is below the given n, and then try to do the same for the remaining one. So my idea is to, for example, for 12, I will take 12 and then I will try to minus 3, and if it is greater than 3, I will try to do 6, and if it is still greater than 3, I will try to do 9, and it's not greater than 3. It's not. So I will subtract 9. 9 because not 6, not 6, not 6. I will have to do the power. So 9 because it is 3 square. So after after subtracting it, I get 3. So this is 3 to the power 1. And yeah, I think that should be my approach. I think that should be my approach. So yeah, I guess that will be enough to that will be enough to calculate it to within the given range. I don't think it will exceed 10 to the power 6. It will not, I hope. So let me see. So uh, I'll say while n. So while n, I'll try to do the uh, power of 3. I can simply subtract power of 3. I guess. Yeah, yeah, yeah. Let's see. So if okay, if it is okay, the naive approach is what I thought. Let me see if I can do that. If uh, if n is if n equals to 1, then that's my answer. That's what I want to have. If n equals to 1 or n equals to 0, and let's see if n is greater than 3, then n minus equals to 3. So yeah, and then if I don't get the answer within the loop, I will return false. Let's see if it works. Time limit exceeded for n equals to 12. So here the while n, so n is 12, and I'm trying to subtract 3, so 9, and then 3, 6, 3 uh, is 3, and then another 3 which is 0. So it should be there. I don't know. Let's see out and Okay, 3 is not. Okay, now it should work. 3 is not greater than 3. That is what is happening. So now I am getting false because it will not come here if n is 0. So I'll have to check here if n equals to 0, then return true. Otherwise, I'll return false. 21. So for 21, what do I get? Okay, it says distinct power of 3. So if the distinct power of 3, I cannot go for it. I'll have to actually take what I thought earlier. I'll have to subtract the biggest one, biggest 3 to the power x that we can have. So for that, I'll say okay, integer x. I'm taking integer x to see how much can we maximize it. So for integer I equals to 0, I is less than, let's say, 100. I hope it will work. It should work. It should work even less. I plus plus, because 3 to the power 30 should already exceed the given constant. So 3 to the power 30, if I do not use anything else, I can use this 3 to the power 13. Okay, uh, 3 to the power 30. It is way big. So it will not take that much, but still, I'm just giving it a number. Now, now I'll try to see if power of 3 to the power x is less than or equals to n, then I will subtract, not subtract, I will do x plus plus. Or maybe something like, okay, I will do x plus plus. And I'll keep doing that, and I will take an ordered set, I guess, an ordered set of integers, and I'll do n minus equals to power of 3 minus minus x, and I'll do if us dot find x equals not equals to use dot end. I mean, if I got the power before, I'll not enter it. I will not enter that. Rather, I will just say return false. Else, I will just add it. Use dot insert x. So I'm keeping in the track of the powers that we used, because I will have to use the distinct powers of 3, and this is what I'm doing here. And I am subtracting n minus, and lastly, if we have any true, it should work now. It I don't know, I'm not sure. Okay, it worked for the sample test cases. I'm submitting it. Let's see. Okay, I got it. Alhamdulillah, I got it. So that's my first problem done for the day within 9 minutes, and I hope I communicated well. I tried to communicate it well. So the purpose of doing this is to get better in communication of what I'm thinking. So I don't know if I could do so, but let me explain it once more. So my idea is to maximize the power of the given n. I am trying to subtract something, a number which will be power of 3. So let's say I'm subtracting y, which is 3 to the power x. I mean a number that is power of 3. So I'm doing this, but I am maximizing it. Every time I'm subtracting, I am maximizing it first. Like how much big you can get, that is 3 to the power x is less than or equals to n. Maximum of 3 to the power x, which is less than or equals to n. So that is what I'm trying to calculate here. Like I'm trying to see I'm starting from 0. 3 to the power 0 is less than or equals to n. If yes, then I'll try the next one, and I'll try the next one. 3 to the power 1, then 2, then 3, till 30. So I'll not reach 30 because 30 will exceed the n, given n, because the given n is 10 to the power 7, which will be done I think in 3 to the power 22 or 3. That should not take more than that. 3 to the power, let's say 23. Yeah, 10 to the power 7 is 9 into 10 to the power 7, I guess. 3, 4, 5, 6, 7. It's big, it's huge number. So maybe even less, maybe 15. uh, 3, 4, 5, 6, 7, yeah, something like that. 3 to the power 14, 15. But I'm taking a number which I will never reach. I will break it before. So yes, I can use a break here, but there's no point because I already did it in 0 millisecond. I don't think we need any more optimization. So the idea is to maximize it. Like I'm taking starting from 0, and if every time I'm getting a power of 3 to the power x, which is less than n, I'm trying the next power, like 3 to the power 1, then 3 to the power 2. So after getting the maximum one, which is less than or equals to n, I'm subtracting it. But if I somehow, for example, 18. So for 18, what I can do? I can 18. I'll try to do 3 to the power 0 first, which is 1. 1 is less than or equals to 1 is less than or equals to 18. Then 3, 3 to the power 1. It's 3 to the power 0. It's 3 to the power 1, and it is still less than or equals to 18. Then 3 to the power 2. It's less than or equals to 18, which is 9. I am sorry, which is 9. Which is 9. And then finally what we have is uh, 3 to the power 3, which is 27, and this is not less than or equals to, this is not. So I'm subtracting 9 minus 2. See, after trying 3 to the power 3, after trying 3 to the power 3, I am getting minus 1, which was valid. Like 3 to the power 3 exceeded, but 3 to the power 2 did not. So I'm getting back to the previous number, the one step down, which was valid one, and then I'm subtracting it. So now I have 18 minus 9, which is 9. Now I'm trying again. This will work. 9, this will work, and then this will work, and then this will again work, because 9 is equals to 9, so I'll subtract it. But this time I already used 2 power of 2, 3 to the power 2 as the power, and again I am here using 2 as the power. So I cannot do that. I cannot use the same power of same powers uh, more than one, because I have given that the powers of 3 should be distinct. So that's why I'm keeping this to track if I used one power before. So if I used one, then I'm simply returning false, which is terminating this loop and returning the answer directly, which is false. And if not, then I'm trying again. I am inserting x, and I already subtract that number and trying again, because the loop will continue till 0. And after the loop is terminated, I'll simply check if I got n equals to 0. If yes, then return true. If not, I'll return false. And it worked.